With the generalized forwarding explained, now let's go back to this notion, the flow table. This is one of the most important things in SDN's data planning. Recall early slide, flow table consists of a number of columns, and you now know it should be 4 columns to be exact. There's this column, priority, okay, and we just ignore that here, as it's not often used in SDN anyway. The stats column is essentially the counter column in the early slide. There are 2 counters, we know, one counting bytes and one counting packets. Action column, 4 classes of actions. One can forward the packet to an outgoing interface, one can forward the packet to the remote controller. One can drop a packet as an action. One can also change the content of the packet as an action as well. So, all these, straightforward. Now, this column here, very complex. Okay. It really depends on the header fields you're using and the values you're using. So the entries, the rule column part of the entries can be very diverse. So the rule column here, in the early slide is also called a header column. The reason it's called a header column is we're using the header fields essentially to compose these rules. In the 3 examples we just walked through, we're using the source and the destination address. These are the header fields in the network layer packet header. One can use other fields in the network layer header for the rule. One can also use fields in the transport layer header, such as the source port number, destination port number, to compose the rule. One can also use the link layer header fields to compose the rule. What's even more amusing is this. These are all fields in the packet headers. One can also use fields that's outside of the packet headers. This is called the switch port. What this means is the packets coming into the router through a particular incoming port. So that's what the switch port meant, the incoming port, the incoming interface. So how we forward the packet can also depend on where they come in from. Right? So that's also why, in this slide, we refrain from calling this column the header column, because we do have a field that's not necessarily a packet header. So we call them rules in general. Let's take a look at how diverse these rules can be, again through a number of examples. First is the destination-based forwarding. And this is essentially the traditional forwarding, where we look at the destination address. So if you have a packet, the header, the destination field says 51.6.0.8. Now we forward that packet to the output port number 6. So you see here, the SDN router can actually emulate the behavior of a traditional router. And the flow table there is actually a very general form of the forwarding table. The second and the third example are there to serve security purpose, to set up firewall entries. So let's take a look at what they're doing. First one is actually trying to match the destination port number header field. So if the packet's destination port number is 22, we drop the packet. The second one is actually matching the source address header field. If the packet source is 128.119.1.1, then we also drop the packet. So you see, dropping packet, definitely, something that the firewall does. Now, why blocking packet going to port 22? Why blocking packet coming from a particular IP address? Allow me to explain. So port 22 is also the port number of the SSH server. So this is the server that you contact to every time you try to log into the workstation. So after you type in SSH, what do you do next? You give the username, right? And then the server is going to prompt you for password. The hackers around the world is trying to SSH into the machines around the world. Using what? Admin or root username and guessing the passwords for the root or admin. Now, if they guess the password right, then they get into the workstation and they get to play around and set things up or change things or encrypt your PA assignments and then send you ransom emails. Okay, so blocking packets to port 22 is to block any login request to port 22. Therefore, SSH is disabled on the machines behind this firewall. Second entry there. Okay, so this is actually more to try to prevent this attack. DOS attack, denial of service attack. You see, system admins around the world, especially those who are experienced, they will go up to these websites where the system admins share IP addresses of zombie machines. So if one day a hacker hacks through the workstation, and take over the workstation, 140.112.42.161 is going to be a zombie IP address. So the experienced system admin, after looking up the website displaying all these zombie IP addresses, can set up these entries with the zombie IPs here. That would actually block all the zombie incoming traffic if a higher level hacker comes in, and asks all the zombie machines to issue, for example, login requests, then our machine is going to under attack. So experienced admin setting up these entries ahead of time will prevent us from the DOS attack. And this attack is also called the SSH brute force attack. Guessing the password by repeatedly trying, that is a brute force attack. Example number 4, destination-based layer 2 forwarding. I know we have not yet talked about the link layer protocols, aka the layer 2 protocols. So this entry here could sound a bit fuzzy to you guys. Now, so let me tell you ahead of time what the purpose of the entry is. So with this entry, the SDN router is emulating the behavior of a layer 2 switch, of a Ethernet switch. I think we've seen something like that when we're talking about the subnet, right? Within a subnet, there are these interfaces that are connected, but the connection is there through a switch, through a link layer switch, or an Ethernet switch. So you see, from one machine, this network interface could have a frame passing through and coming to the link layer switch. Now, this link layer switch, we need to look at the destination address, but the link layer destination address to decide how to forward it further so that it reaches other interfaces on the same subnet. Okay, so that is the use of the switch there. So you see why. This entry here is looking at the destination address at the link layer. That is also called the MAC address, and it looks very different from the IP address. So if this packet comes in matching this link layer address, then that's forwarded to output port 3. Right? So that is the idea.